Ever hit a wall when your tool needs user input, but you don't want to hardcode options or deal with free-form text chaos? You'll see how to constrain user responses to specific choices, like low, medium, or high priority, using FastMCP's elicitation, ensuring clean, predictable input without extra validation code. The pattern handles the response as a typed value, so your tool just reacts to the selection. At MCP, tool. Async def set priority, ctx, context, SDR. Set task priority level. Result equals await ctx, elicit. What priority level? Response type equals low, medium, high. If result action equals accept. Return F priority set to result data. This demonstrates interactive tool composition through user elicitation, a pattern that enables dynamic data collection during execution. Unlike traditional RPC, where all inputs must be provided up front, elicitation allows tools to pause, request missing or clarifying information, and resume with user-provided context. The distinctive aspect is its conversational flow, transforming static functions into adaptive workflows that can handle incomplete or ambiguous requirements. The pattern works by treating user input as a first-class dependency, injected at runtime through a structured request-response cycle. Tools declare their data needs through type hints, while the framework manages the elicitation protocol, validation, and result handling. This creates a clean separation between the tool's core logic and its interactive requirements, with the context object acting as both the mediator and the state container for the conversation. This approach solves the problem of rigid input requirements in automated workflows, making tools more resilient to real-world variability. It's particularly valuable for AI integrations, complex forms, or multi-step processes where not all parameters can be known initially. The trade-off is added complexity in client implementations, which must handle the elicitation protocol, but the result is significantly more flexible and user-friendly tooling. Let's break it down line by line. At MCP, tool. Async def set priority, ctx, context, SDR. Set task priority level. The @MCP tool decorator registers this function as an AI callable tool in FastMCP. The docstring and type hints automatically generate the tool's schema, defining its interface for AI models. All FastMCP tools must accept a context parameter for logging, progress reporting, and user interaction. This pattern ensures consistent tool integration across the framework. Result equals await ctx, elicit. This triggers FastMCP's interactive elicitation flow, pausing execution to request user input. The await handles the async response, enabling the tool to collect the priority level before proceeding. What priority level? This is the user prompt for the ctx, elicit call. It defines what the AI will ask the user, ensuring the interaction remains clear and directed. The prompt's phrasing directly impacts response quality, so it must be unambiguous and actionable. Response type equals low, medium, high. This restricts user responses to only low, medium, or high values. It enforces input validation at the elicitation level, preventing invalid priority values from entering the workflow. This closes the ctx, elicit call, finalizing the interactive prompt. Without this, the function would be syntactically incomplete, preventing execution. If result action equals accept. This checks if the user explicitly confirmed their input. FastMCP's elicit returns an action field that's either accept or reject, And this pattern handles the success case where the user's priority selection is valid and confirmed.
Return F priority set to result data.
This returns the confirmed priority level to the user. The F string formats the response with the validated data from result data, ensuring the AI receives a clean, structured confirmation of the action. This pattern maintains consistency in tool responses across the FastMCP framework. Elicitation pattern, FastMCP's ctx.elicit, transforms Python functions into interactive dialogues, where type hints become conversation constraints and return values become user decisions. The response type parameter silently enforces validation, passing a raw list of strings works, but using literal or enum makes the contract explicit and type safe. Always handle the action field first, except decline and cancel are the only outcomes that matter.
The question that asks for nothing receives everything.